use these two things, and finally we can show that S is bigger than this AI Q naught square, and then this term comes here. Now you have to choose your. Now one can check that in the right hand side. So this equation is independent. This equation is independent of the choice of F. So we will choose F in such a way so that this CF Q naught M square is bigger than that. This term it will become this right hand side of the above. This inequality will be always positive. So it is always non-zero that we will get it. CFM Q naught square, absolute value square. Okay, so this is the standard technique that we usually adopt to show that the first non-zero coefficient. What is the n where this first non-zero coefficient will occur? Okay, so one has to note that the right hand side there is a square here, and we can check that this is always the quantity is positive. Whenever we choose our x bigger than equal to this particular, remember the theorem that we were stating, k naught n into 3 minus 2 epsilon for plus 4 epsilon n over q naught, and this is the exponent that was coming up with c equals to half plus epsilon. Okay. So whenever we choose our x bigger than equal to this, the right hand side will be always positive. So this completes the proof of the main result that we had. Of course, I mean, some work is there in between which I have suppressed. And but if one is interested, one can have a look at the paper which is there already published. And let me give you some of the references that I had used. That was the paper of Das and Anambi. Those two papers that I was looking at it. There's some other work I did long back with Petri Yanis and Srinath Baba when I was a postdoc there. This was for Ziegel modular form. It's already known, this result. And for Hilbert modular forms, one can look at this was Dinakar Ramakrishna's result. That was Hofstein-Lockhart result that we were talking about. There's some relationship with the L functions that we were talking about. One was by Harkos. And of course, we have this standard texts. That was Shimura's result. Thank you so much.
Thank you, sir, for this nice talk. So now we are open to questions or comments.
Can I ask a question, Kalyan?
Sure, Dipendra. If I can answer, yes.
No. You see, I always like to think in terms of elementary things. How does this relate to one variable proofs which are available? So I do not know what are the various proofs available in one variable.
I mean, one variable means this same square free thing was Das and Anambi's proof that you were talking about.
So they did it for
classical modular form, yes.
Classical modular forms.
Yes.
And what would you say is the crux of their proof?
Yeah, their proof also, the first one, they did not use this Rankine-Selberg. And I think they got a bound which was not very good. It's of exponential type, so that not much of use. But in the second proof, they used this Rankine-Selberg convolution, Rankine-Selberg L function theory, Rankine-Selberg theory, and they improved. So more or less, we had a similar, we used similar technique, but in the more variable case.
So you would say Rankine-Selberg convolution is one of the main inputs.
One of the main input, and the relationship between those, yeah. So that result of Shimura, that this calculation of the residue at s equals to 1,
yes,
and some relationship between some variant of this Rankine-Selberg L functions that has been used, because somehow you have to bring in this square free part. But basically, it is Rankin-Selberg convolution that which is the main tool here.
I mean, the point would be that if many Fourier coefficients are 0 for f, then for the Rankine convolution also many of them will become 0, and you can then estimate it, which will go against the estimate on Rankine convolution.
Yeah, it seems like that's the main idea behind it.
Okay, good.
Are there any more questions? Okay, looks like no more questions. So let us thank the speaker. And let us thank speaker of both the speaker of this session.
Thank you so much, Anu. Nice seeing you, seeing all of you.
Okay, so we have a tea break. So I give the floor to Rashi.
Yeah, so thank you, Dr. Anu, for chairing this session. And I would also like to thank the speakers of this session, Professor Kalyan and Professor Rajan. So, Gayatri ma'am, I think we can stop the live stream now and also the recording. So, yeah, so we'll resume at 5 p.m. Indian Standard Time. And the floor is open if people want to talk and discuss.
The live stream is not working. I thought maybe it stopped. Whenever I see this one.
No, so the link is changed, sir. For this session, the link is changed. So it is there on the website.
No, I went to the website only. I changed the live stream. Each session is changing or what?
No, for the second session, we just changed it.
But maybe
After
I have
this
to reload the web page. Then I have to do.
Okay.
Because I have one conference page where I click it. It says video unavailable. That's okay.
Can you just check, Rashi? Maybe
Yeah, I'll just check
check
that.
with